My talk will be again about challenges, unfortunately. Looks like most of the talks in this conference should be about this. But I'm going to make it as fast as possible, as I am the last one. So challenges in the clearing and settlement quality assurance this time. At first, I would like to put you in the context. So this picture shows components of the complex clearing systems. You can see a number of internal components that make a number of different tasks or incorporate several tasks in it, and a large number of connections to third-party systems or in-house external systems, such as markets, market data providers, CSD, payments systems, banks, and of course connectivity to clearing members. And as we at Exactpro have experience of testing such kind of systems, we faced some challenges during this process, and I would like to discuss several of them and discuss the way we address them. So that's the list. Let's start and discuss each of them in more detail during the next slides. At first, we need to deal with the participant structure complexity. A company can be represented by different entities, and these entities might trade at different markets, different asset classes, and even margining process could be done in consolidated way or in segregated currencies if several markets are cleaned in the same clearing house. In addition, non-clearing members and clearing members, the links between them may add additional obstacles to the picture. For example, non-clearing member could clear via one clearing member in one market and another clearing member in another market. And if we test the infrastructure for CCP who works on both markets, that's the task for this CCP to do it properly, and that's the task for us to test us that this is done properly. The next point is that we need to take the full position lifecycle into account, which would normally span across multiple days and include dozens of steps. It would be wrong to focus on specific point of the clearing process, such as trade input or settlement session, and avoid all other processes. And it's vital to consider all the stages of position lifecycle to complete this scenario. Here are a few examples of such end-to-end scenarios. Collateral deficit. To test this scenario, we need to input trades, initiate risk computation, receive margin call, simulate collateral delivery from the member, and then initiate the next round of risk computation to see what we've got from the whole scenario. For delivery default, we need to do even more work because this is a multi-day scenario. We need to wait till settlement date to do all necessary steps during trade dates and pre-settlement period, and to simulate delivery failure, to initiate buy-in process, cash settlement, and so on. And the corporate action, which also requires several days to make sure that we capture all necessary steps before and after execution of corporate action. Next one, risk computation, which is the heart of clearing system. It requires real-time data and historical data, and it's also normally based on complex mathematical models and use powerful computation algorithms. So it includes value, risk, expected shortfall, yield curve shifts, span, and so on. So there could be different algorithms which are implemented or should be implemented in the system. And so it's quite time consuming and requires specific knowledge to test them. Next one, asset classes. So if clearing of different asset classes involves different processes in the CCP and different algorithms, but if cross-asset clearing comes into existence, then cross-asset class margining comes into existence, it adds even more complexity to our challenge. And the next slide illustrates how upstream, downstream systems dependency of clearing system environment, how it adds complexity to our picture. Upstream and downstream systems, their availability during testing phase is usually limited, because to have the full CSD environment during the whole time of testing is quite time and resource consuming. It's not usually the case, and so for other interfaces, and therefore we need to properly simulate all these interfaces during the testing. And access to variety of API endpoints such as Fix, Swift, MQ, FPML, and custom interfaces should be also supported by a test tool during the testing. So if you combine all these previous points, you will reasonably get a huge test library. And we came up with the solutions to deal with these challenges. A holistic, integrated, automated test framework is illustrated in this slide. I'm going to focus on just a couple of case studies, and if you are interested, we will be glad to discuss it after the talk, or welcome to our website. But let's focus on a couple of them. So the first one is simultaneous execution of multiple end-to-end scenarios. Most of them are spent across days and involve large number of steps. Moreover, those steps should be aligned with the CCP processes. So let's briefly go back to the examples that I showed before. So it's collateral deficit, delivery default, and corporate actions. That's just an example. ClearTH is the test tool created by Exactpro. It allows us to execute those test scenarios and many more in batches. Test execution is split into global steps, and each scenario is aligned with these steps, with these global steps, and this way we can execute as many as possible, a bunch of scenarios at a time, and make sure that we incorporate them into in the clearinghouse schedule, into CCP schedule. Another case study is verification of risk computation. In some cases, we create a model and redo the calculation using our software, and then compare it to the results achieved by the test system on the test. In other cases, we can run a bunch of specific tests and take the results and use it as a baseline for the tests during future versions of the system. The tool which we use for this is called Risk Analyzer, so you can see the name on top of the slide. But as a whole, it's also part of our ClearTH solution. It can be a part, it can be separately, but we used to call the whole our solution as a whole ClearTH. And the last for this presentation is high volume automated testing. It's sometimes not enough to have a predefined set of predefined test cases, and issues may arise during when the system is under high load. And for this case, we first input the random load and make snapshots at all valuable points, all valuable steps which aligned with CCP's lifecycle, and verify consistency, check logs, and monitor GUI and API. And the next round, we execute the test with the new software version or under different conditions, for example, failover, and compare those snapshots. If a discrepancy is deducted, then that's a place where a possible bug could live. So we need to dig into detail and find those bugs. That's all for this presentation. If you have any questions, we will be glad to hear it here or to answer it at any time. Thank you.